Welcome back, everyone. I've got another interview. This one's a special one from me. So I worked with a gentleman for many years. His name was Murray Hodges, and he started a company called FLUIDSENTRY, and it's a safety concept for hydraulics and pneumatics. And I'll leave it at that for the moment. But I want to introduce you to his son, Jason. Hi, Jason.
G'day, Cliff.
Unfortunately, Murray's no longer with us, so that's the reason we're talking to Jason today.
Nice to be here.
So, my first question to you, can you remember when your father decided to start this business and how it all came about? Because I think he told me a story about where he almost perished in an accident.
Yeah. So Dad was an apprentice fitter at a site here in Victoria, and he was asked to go inside a hazardous area and do some work on a maintenance day. And there was a second team doing some work elsewhere on this piece of equipment.
Yeah.
While he was inside the hazardous area that he was doing the work on, where he tagged out, the second team had actually removed the control equipment. That was their task for the day.
Wow.
But by moving the control equipment, removing it and swapping that out, they'd actually taken the equipment with his tag attached to it.
Oh, God.
And installed the new equipment and started the machine up. And he very promptly left that job and raised the concerns. But this was in the early 90s or late 80s when this occurred. So it was a very different landscape, safety-wise, especially here in Victoria, right? Like, things have come a long way in the last 25 years. It's very, very different then.
Well, to my understanding, so I met him, I think it was the early 2000s, might have been about late 1990s, I can't remember the exact date, and I remember he said as a result of that incident, he became passionate about safety.
Dad was always passionate about rules and legislations and standards. Always. That's my memory of him, right? So I was born in the 90s. Yeah. So, Dad had started this, or at least this idea had started for him, around the time that I'd come along. Mum tells a story about him going out to work for himself, like when I was 3 months old. So brand new baby that's just arrived, and off he is, fighting his passion, or trying to get something that...
Well, I have a feeling you weren't that old when I first met your father. I can't remember the exact, but anyway, the thing is that, so this is the point I'm getting at. He was an electrician by trade, and he dabbled very much in the safety side of electrics and so forth. And apparently, the way he put it to me, one day he was sitting there looking at a safety relay and suddenly realised there's nothing like this for the fluid power industry.
Yeah. I think he had the idea, and he then went out and sort of shopped the idea around.
Yeah, that's right.
So he was doing a bit of work for GM here in Australia on the paint lines. Yep. And the engineers there, he started talking to them and he said, "What do you think of this idea?" And they went, "That sounds like a really great idea. What do you think about a safety relay for fluid power?" And they went, "Oh, that's an interesting idea, Muzz."
Well, that's the thing, and so that's when he'd been well into the development of it when I first met him. Yeah, and I was privileged to be there at the early stages where we went through some very interesting trial and error. Building different systems. I remember the old logic system. My God, it worked brilliantly, but my God, to make it meet the standards that he had set was incredible. So I just want to back up a second. I just suddenly realised the viewers, a lot of them might not even understand the difference between what is a safety relay, both electrical and from a hydraulic point of view. Maybe you can give your answer.
The easiest way to explain it is just like the safety switch on your house.
Yep.
So every home in Australia has a switchboard.
Yep.
You might be old school and have some fuses in there still, or you might have actual safety switches.
Yep.
It's a switch.
Yep.
It turns things on, it turns things off, but it's a little bit more convoluted than a regular light switch or a water tap in your backyard. These things, they have to follow standards of redundancy.
Yep.
And reliability. And there's always, well, I shouldn't say always, but for a long time we've had electrical products that control electrical circuits, both in residential, commercial, and industrial applications. But it wasn't until Dad came up with his idea that there was something for fluid power.
That's right.
And as far as energy sources go in industry, Electrical power is really good at doing most things, but it just doesn't have the grunt that fluid power does.
That's right.
So, you know, up until 2000, there was nothing
That's right.
governing the safety of fluid power like our device does.
So again, for the viewers, in essence, I'll make this simple. So with electrics, flow is amps and pressure is volts. Okay.
Yeah.
And in a hydraulic system, you've got a fluid under pressure, and you can have very high pressure and you can have very high flows. And in essence, what Murray did, he created a valve or a series of valves, both for pneumatics and for hydraulics. And its sole purpose was that it's normally open. The hydraulic system or the pneumatic system functions, the air's flowing or the oil's flowing, not a problem, until it senses there's a problem, and that signal can come from a safety relay, can come from a pre-programmed situation, whatever, opening a gate. So someone goes in, and what it does, it literally closes and prevents the pump from supplying pressure and flow into the system. That's it, in a simple term.
Yeah, so it removes the hazard of
right.
whatever the fluid is, right?
Yeah.
It stops anything new coming into the system or the hazardous area, but it also takes everything that's in there away as well.
Yeah.
And then with some ancillary devices, you can, you know, verify that that's all been taken away before you grant access. So it just makes sure that when people get up and close with equipment, the hazards are removed.
Yeah,
and it means that they can go in and be comfortable that a hose isn't going to burst and, you know, come around and knock them out or knock them unconscious or fit worse.
So I want to come back to Murray now. So Murray developed this from scratch, and he developed a company called FLUIDSENTRY, and he developed a product that was dedicated to safety in the pneumatic and hydraulic industry, which is encompassed by fluid power. And the interesting thing is, not long after he hit the market, a lot of the big players in that industry suddenly went, oh, hang on, and started to try and copy it. Now, Murray decided, because he wanted to produce a system that's purely for safety within this area. He did everything right. So he came up with a failure, what's the FMEA failure?
Failure modes and effects analysis.
Yeah, effects analysis system. And whenever anything in the developed process never met that, it didn't go ahead.
That's right.
It's as simple as that.
Yeah.
And so it was a very high standard. So as Murray developed these valves, obviously the competition could see a marketplace, and they started making copies, versions of their own. They take their own products and create a safety version of them. But they were never as good as the FLUIDSENTRY one, simply because of the fact that from the ground up, it was developed as a safety valve.
Yeah. I think the important thing to know is, like, the standards that Dad designed the products to were what's called a B-type standard, right? So they're very broad standards, and there was nothing specific to what you should do in this space.
Yeah.
So he was taking stuff that was written perhaps mostly aimed at electrical circuits and applying that to fluid power circuits.
That's right, exactly.
And it's not a one-to-one translation a lot of the time.
Well, that was part of the joy of working with him, because in the development process, and that's what I'd say, this is actually the heart of what I believe why the FLUIDSENTRY product is superior, because we learnt so much by that trial and error and what to do and what not to do. So, sorry, continue.
And then that's it, right? Like there's 20 years of history of the company, like longer now, but of the way that Dad did R&D was very much, you know, by the seat of his pants. Let's get it in the machine and let's try it. Because it's a challenge of my job these days, explaining fluid-powered circuits and why they do what they do and what they're going to do is, you've got a history in the industry, Cliff, you know. You know, the physics all make sense if we do it down mathematically on paper, but what actually happens in the field, there's a lot of variables, let's put it that way, right? So, you know, when the products were designed...
Let's touch upon a most basic one. So one of the things that your father was absolutely, and excuse the expression, but anal about, he would not touch proximity switches at all.
Yeah.
It had to be a direct acting switch. He went to the trouble of finding a mechanical switch out of Germany that was so highly rated that, you know, Yeah, it was so safe.
And we're still using the same switches today.
Yeah, but the point is that's an example. I used to do my head in. We were trying different switches, and we get to. And I thought, oh, they're working well, and he'd go, no, gone. And
Yeah. Let me put it this way, right? The work that Dad did and that you were a part of, and the other collaborators who were there, we can talk about that in a moment, not a single FLUIDSENTRY product that we've ever sold has failed to a dangerous state.
Yep.
Ever. Quarter of a century, never. It just goes to show that good design.
Exactly. And this is the point
tenfold, right?
I'm trying to make, is that coming right back to the fact that they were developed as a safety valve or a safety product. They were not developed as a hydraulic or pneumatic valve.
That's right. Yeah.
And that's the key to their success.
The thing in industry is the standards don't say, it's not a prescribed task, right? The standards don't say you must do A, B, C, and then D.
Yep.
A lot of the times they have, legalese, quite broad language. People have an obligation to be safe at work. Employers, owners have the obligation to make sure people are safe at work. And then there's some standards and there's regulations that give you some guidance on how to do that.
Yeah.
And then there's best practices as well. But when something goes wrong, that's when we really find out whether what the designer or integrator did was up to standard, or I shouldn't say standard, but up to muster, right? Whether they properly, crossed all the T's and dotted all the I's. When you've got a product like ours that's been around for so long, it's got a track record of reliability. We can say pretty confidently that we know that if someone's using our product and it's installed correctly, then you can rely that the fact that it's going to work, right? Not to say that our products haven't failed, right? But there's fail safe and fail dangerous, and our product is designed to be fail safe.
That's exactly why they're designed for that purpose. I mean, that's the
and it's the same reason why we have reliable safety switches and fuses in our houses, because we know that they work. So that's why we do it.
Yeah.
We're not taking a punt on safety. We know that it works, and that's why we do it, and that's why we continue to do it now.
Yeah, and I think it's fantastic that you, Murray's son, is now continuing the tradition. I mean, it's just I love it. I mean, he was a fantastic guy. He had his quirks. He's an interesting guy, but Murray and I built a strong friendship, and I sort of miss him in some ways, but it's good that I can actually talk to you. So. What else can we talk about in respect to at what age did you realise that what he was doing was pretty special?
In school, every now and then you do an activity, right, where they go, what does mum and dad do?
Oh yeah.
And there were people in class. You had the typical dad's a firefighter, mum's a nurse, those sorts of things.
Yeah.
My dad's a lawyer, yada yada. And I'd sit there going, my dad's...
How do you explain this?
My dad's an inventor, was what I said for a long time. I forgot what he invented.
Well, he was in a way.
Well, yeah. I'll put it this way, right? When Dad passed away, or when anyone passes away, you're asked to put their occupation on their death certificate. And our family sat around for a while to go, what was Dad? And like you said earlier, he was an electrician. He was an A-grade electrician. And he always, he kept his papers up to date. So to the day he died, he was still an electrician. But I don't think anyone other than my dad could have come up with this product, right? Because his unique blend of skills.
I agree.
He had never really held down jobs for a very long time. When I'd sit there talking to Dad about his childhood, he'd tell me stories about working in my grandfather's boring company. He worked in my grandfather's fishing company. I don't know what else my grandfather did. He did 100 different jobs. And Dad was always there. At one point, Dad was there as a Bowser boy, filling petrol for cars, And then when he went off to, as an adult to go and find his own career, he worked for some of the companies that became our competitors. He worked for SMC, or worked with them. He worked for Festa. He worked for Norgren.
That's right.
As in sales roles and other roles, and so he learnt this mix of electrical knowledge
and mechanical
and fluid power knowledge. Mum tells a story about a point where they sat down together and decided whether Dad was going to go and do proper qualifications. Was he going to go and do night school, or was he going to go to university and get an engineering degree?
No, I didn't hear about this. This is interesting.
And they ultimately decided, well, let's do the night school route. And he talked about how that decision plagued him, because he struggled to garner respect in the industry because he didn't have engineer next to his name.
Yeah.
But he knew this stuff inside and out, and he could talk the talk and he could walk the walk.
Can I tell you my nickname for him?
What was that?
Ben Lexon.
Ben Lexon.
Ben Lexon. You know who Ben Lexon is?
No.
Oh my God.
Enlighten me, please.
You know the America's Cup?
Yeah.
You know when we won it?
Yeah.
After 100 years, we beat the Americans?
Yes.
Ben Lexon was the guy that invented the wing keel for that yacht. So it may not be something you did, but Ben Lexon was like your father. He didn't have any qualifications.
Mm-hmm.
He was just this walking genius, and he could just think about things outside of the square.
Yep.
And come up with things. For 100 years, countries would compete with the Americans, and the Americans would throw millions of dollars at it, and always win. Ben Lexon came out of the woodwork one day and agreed to basically design, and they kept it secret, come up with this principle. Everyone thought he was nuts. History, look it up.
Yeah.
1983, I think it was, the America's Cup, where Australia beat...
it was a big deal.
Oh, man, it was massive.
It's a big deal.
It was such a big deal. You got the Prime Minister of the day, Bob Hawke, saying that any boss who sacks a guy for taking time off to watch this is a bum. Yeah.
Yeah. No, it's still in the lexicon. Absolutely.
So there you go. So as far as I'm concerned, your father was up there with Ben Lexon. And another piece of interesting information, Ben Lexon, the Toyota Lexus car was named after him.
There you go.
Bit of history for you.
There you go.
And that's... Your father's up there, as far as I'm concerned. I wish we could name something after him, but his legacy with FLUIDSENTRY is, to me, phenomenal. And, even if the company eventually disappears, the principles that he developed and which will the basis for other safety industries, they're there.
We have the patents framed, right? Like for anyone who's seen a US patent in particular, they're very shiny and they're got gold stuff on them, and they're very regal looking documents.
I remember the day Murray came, he rang me up and said, come down.
Yeah.
And he wanted to show me this patent.
So we've still got those, and we know that the way that patent law works in every country is designed to foster innovation and allow people to build on other people's ideas, right? So he was the first one to get a patent for this sort of technology. And the fact that people have built on it is an honour to him. Right?
There's the awards that he's won over the years.
Yeah.
My God, I know the Victorian government and the federal government. He won a number of awards there in respect to safety.
Yeah. I think the hard part, I remember around that time was when I first started to properly become aware of what Dad was doing, and I remember hearing him talk about the process of those awards, because you sort of have to be nominated and apply and explain what things are. And there was a couple of safety organisations around the country that were running those awards, and Dad would talk about how he would present his business and the products to them, and they would sit there with blank looks on their face. What is this, and why would anyone want it?
Yeah.
And that was the first 10 years, 15 years of challenge, right?
It still happens now. I understand, even from, you're still there.
Yeah.
And it's the challenge, trying to get people to understand the principles.
Yeah.
People, even today, let's forget safety for the moment. When people ask me what my history, and I talk about hydraulics and pneumatics, and I get this sort of glazed look, and I think, what the hell is that? They have no idea. Most people have no understanding. They know the word hydraulic and they sort of think of maybe an excavator or something, but they have no understanding of how much hydraulics and pneumatics underpin the manufacturing processes and how dangerous they can be.
Yeah. So. I mean, it's everywhere, right? Like, technically your house is full of hydraulics, right?
Absolutely.
That's how your bath gets full. So, people don't actually realise. Even the people that work, and this is the part that concerns me, the people who are working with these machines, the operators at food co or manufacturing company,
whatever,
I don't think those people a lot of the time understand.
I know they don't.
One of the things that I do on a regular basis is I read the alerts that come out of the accidents and fatalities that happen around Australia, and lately that I'm looking at a more global stuff, I'm looking at a lot of stuff that comes out of the UK and the US. And when I started in this, working with Dad, was one of the more confronting part of the jobs. Was,
I can imagine.
Reading an article, when did I start? I was in my early 20s when I started. And someone the same age as me has died because of something that's happened. There's a story that I tell in some of the training that I do now about a boy named Day Davis who was at a bottling plant in Florida, and he was a temp worker. He died on his first day of work.
Oh, God.
You know, so this person didn't know what the machine was capable of.
Yep.
Well, sorry, I'll give him a bit of a doubt. Maybe he did know, but you know, he wasn't protected, and you know, a terrible thing happened to him and his family, and you know, it shouldn't have happened.
No, that's right.
Should never have happened, right? And that's the situation where, you know, I read these things and I go, preventable, 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 preventable. There was something that happened only this week. The industrial manslaughter charges, the first case was tried here in Victoria since those legislation is launched.
Oh, wow.
And reading through that, the people running that case, someone said, and I wish I could quote the person, but I can't remember who it was. They said, you know, there's no such thing as an unavoidable workplace accident.
Absolutely.
And I think that's so true.
Well, look, this interview, I didn't want to go too long, but we're going to go a bit longer because I want to touch on this.
Sure.
One of the things that your father used to do, he would arrange for seminars, is probably the right description for them. And he would arrange for people within the industry, right through, from people who worked on the ground floor right up to barristers who prosecute safety issues.
Yes. Yeah.
And he would get them together. Matter of fact, I filmed one of them, and I might even put this up on this channel. And it is a real eye-opener, especially when you get into the legal side of things. And one of the things that I think a lot of businesses do not understand, if you at least make the effort to try and protect your workers, then in the case of, and this is very general, in the case of legal prosecution, you'll be looked upon more favourably than if you are blatantly just ignoring. You know? And what that means is that as a business owner, you have to make yourself aware of the dangers of the equipment, the manufacturing processes that you've got, and what is out there with available technology to implement that would make it as safe as it can possibly be made under the current conditions. And if you do that, more importantly, you're saving people's lives, but you're also protecting yourself.
Responsibility has always gone all the way to the top in businesses. As far as the you know, everything's written, that's, you know, in practice it didn't seem to happen that way in the past.
Exactly.
Whereas the industrial manslaughter charges now make that very clear. You know, you face ultimate responsibility for the gains and losses of your business as a business owner or a senior manager, and that comes down to fiscal and, you know, tragic losses as well.
I'm making a decision right now. I'm going to put this video up. It's a long video. At the moment, I've got it up on another website, but I'm going to put it up on the YouTube channel. And after this interview, it might be worth your while having a look at, because it really is very interesting. Anyway, sorry.
And I've seen it. You know, it's a great session. The hard part, like we said, communicating in this space to people that aren't safety minded or mechanically minded is really challenging, right? Which is how over time I've come up with my, you know, your circuit safety switch or your fuse box analogy, right? Because people get that. Trying to communicate. I know when I first started in this space, trying to understand, you know, things like Bernoulli's principle, right? Like to try and explain that to someone with no knowledge or no practical expertise in the area, they go, and their eyes glaze over, and they go, okay, but is it safe, right? And look, it is a fair statement to say that FLUIDSENTRY's products, our double block and bleed products, it's not the only way to solve this problem.
Oh no, of course not.
You know, you can solve hazardous energy by going off and turning off the isolators.
You can completely lock it out, put a big fence around it, turn everything off, power off, and you're just as safe.
That's it.
But, and as I said, I didn't want to go on too long, but this brings back to one of my favourite topics about this, and I've done massive amount of research on this over many times. You've seen some of it. The reality is the cost of up front, they see the technology seems expensive, but when you sit down and do a cost analysis, and the prime example, I'm not going to name the company, they had a manufacturing process and they used to have people having to walk in, and because things would fall off the production line, they used to have to shut the damn plant down and go in. So Murray and I went up there one day and we installed safety valves in zones, and we put gates, and the gates were tied up to the valves. And so what would happen was that something would fall off, the operator would open the gate. As soon as he walked in, the system still kept running. They didn't have to shut everything down. But that section of the production process, the safety valve kicked in. There was absolutely nothing that could go there and do any damage to the person. They can go in and do what they want and come out. And I sat down and did a cost analysis on this one day, and I think it was within a 12 months, 2-year period, they would recoup the cost of their valves, and then going forward, they would actually have a savings, like make money on the installation of these valves. Anyway.
It's a really quick return on investment.
It really is.
Look, we know our product works. With that site you're talking about, I've been out there since I joined the company.
Yeah.
I think it's been out there getting on 20 years
Absolutely,
now.
the systems are running.
The same valves are out there, Cliff.
Are you kidding?
The same valves are out
there. You do realise they're the original logic valves that oh my God.
Yeah. I think there's been 3 solenoids or so that we've replaced. But
I better explain this. The original, especially very large flow valves, Murray, I helped him. We built logic. So what they were, very large blocks with logic elements in them, and they could be open and closed, and you have massive flows go through. But they were a highly difficult valve to manufacture and produce and stabilise. And so we went from that to another product, which now Jason sells and creates. But so I cannot believe 20 years later, they are still running. The testament to the engineering.
Yeah, and that's it. That's absolutely it, right? Like we have reliable products that last. And then again, without bogging down your video, right? We've made a commitment that we'll keep stuff going as best we can, right?
Yeah.
So alternative solutions that are available to customers when they have issues.
Yep.
Those suppliers say, well, buy a new one. Throw it out and buy a new one. We say, let's swap, go to your storeroom, swap it out, and we'll have it back here and we'll have a look at it. Yeah. And a lot of the time, when we do our inspection on it, we'll look at it and decide whether or not we think it's reliable and safe to send it back to you. And if we can repair it, we'll repair it.
I remember
so you turn an investment of, you might be, a couple of $100 every other year if you're replacing the whole valve. The other thing too is like our products copper beating, because they're at the front of the circuit.
Absolutely.
They're the first thing in the same thing with your house, right? The first thing in your electrical circuit in your home is your switchboard. Our product, because it's there to isolate everything, it's the first thing in the product in the circuit.
They're deep in the manufacturing process. I mean, they've got heat, they've got cold, they've got piece of equipment knocking them, all sorts of stuff.
And they cop the contamination that's in the tank.
Absolutely.
So they do copper beating. But they work and they last. Yeah.
They work and last. Yeah. I'm testament to that. I've repaired many of them over the years. I mean, they staggering. I remember one valve we got from BHP. I can't remember, and it was almost black on the outside. And Murray and I looked at each other and we thought, we cleaned it up, pulled it apart. We couldn't believe it. The internals were fine. We just replaced a few seals, put it back together. And
It says a lot about our suppliers as well. Like we have had the same suppliers. With our current iteration of product, which we've had around, again, nearly on 20 years. I think it was 3 versions in the first 5 years, and then we went, we've got one that works, don't change it. So those partners that we've had there, we've been working with them for, nearly a quarter of a decade, century as well, right? So it goes to show that they make a great product and that, we've got a really good relationship with them and we're able to put something else into the field.
Your father would be so pleased, Look, I think we're going to wrap this up, but I want to give you the opportunity. Anything final to say about FLUIDSENTRY and your father and whatever?
It has been a journey and a challenge going through, the last nearly decade that I've been with the company. It gives me a lot of pride to have this opportunity and to have done what we've done with the company. I'm really proud to tell people about what Dad did with the company and what he did with his life. When Dad passed away, I spoke at his service and I said, we don't know how many lives Dad saved because we don't count those things.
No, you can't.
But I often think about that, and I wouldn't even know how to put a number on it, right? How many near misses or fatalities or stuff have been avoided?
Absolutely.
Because the system worked the way that whoever designed it, right? We report close calls, but again, how many close calls are missing? So. I really appreciate all the work that everyone who collaborated in the business has put into it over the years, and there's been a lot of people that have put effort into FLUIDSENTRY over the years, and I'm really proud of where that whole team has gone, you know, both under Dad's leadership and then under the leadership we've got today. It's been fantastic. So
thank you.
Here's for another 25 years, I hope. And,
well, look, thank you very much, Jason. And I just want to finish by saying that it has been a privilege, first off, knowing Murray, his family, Jason, I was lucky to encounter someone like Murray in my life. So anyway, everyone, thank you for watching, and we're going to sign off. Bye.
See you later.